Hey guys, it's Mrs. Rajewski. Today we're going to be talking about solving systems of equations and solving systems of inequalities. So go ahead and let's get started with the warm-up. Our first problem here, we've got to solve this multi-step equation. I'm going to start by adding 6 to both sides. I'm also going to subtract 4m over to the other side. Whoa. So let's see, that's going to give me negative 3m, which is equal to 14, since 8 plus 6 is 14. We're going to divide both sides by negative 3 to get m alone. And we get m is equal to negative 14 thirds. This is a fraction that cannot be reduced. So this is our final answer. Wow, that was crazy. Problem number 2 gives us 4n is equal to 9 minus 2n. I'm going to start by adding 2n to the other side. It's best for us to get all of our variables onto the same side and move our numbers or constants onto the other. So I've got 4n plus 2n, which is 6n, and this is equal to 9. So we're going to divide both sides by 6. And we get n is equal to 9/6. This is reducible, so the top and bottom are both divisible by 3, so we'll get 3/2. And lastly, for problem 3, we've got 1/3 of t plus 5 is equal to 10. And I'm going to start by subtracting 5 to the other side. And I've got 1/3 t is equal to 5. Since t is getting multiplied by a fraction, I can either multiply by the reciprocal or I can just multiply both sides by the denominator. That's the strategy I'm going to use. If I multiply both sides by 3, 3 divided by 3 is 1, so I've got 1t, or just t, is equal to 5 times 3, which is 15. Okay, for problems 4 and 5, they ask us to see that the system is a solution, that this point that we're given is a solution to the system. What that means is wants to see if this is a point that works for both equations. Ultimately, if it does work for both equations, that means that that's the point where those two lines cross. So the best way for us to figure that out is to actually just go ahead and substitute these values in. So in this first one, our point is 5, 1, so our x value is 5 and our y value is 1. And we're just going to substitute those values into the equations, see if we get some true statements. So I've got y is equal to negative x plus 4. Well, negative 5 plus 4 is negative 1. And the last time I checked, 1 did not equal negative 1. So that is a no. I don't even have to do anything else. That's definitely not a solution. They're not going to cross there. For problem 5, we're going to do the same thing. Again, here we've got an x value that's 2 and a y value that is 2.4. So we're just going to substitute into these equations. I'm going to start with the top. So we've got 4 times x. We know that x is 2, so we'll substitute that in. Plus 5 times y, which is 2.4. And that's supposed to equal 20. As you know, 4 times 2 is 8. And then 5 times 2.4 is actually 12. And 8 plus 12 does equal 20. So hey, maybe we have a solution here. But hold your horses. We still have to test the second equation. So the second equation says 2x plus 6y is equal to 10. So 2x plus 6 times y is supposed to equal 10. We'll see about that. So 2 times 2 is 4. That's great. But 6 times 2.4 is actually 14.4. And 14.4 plus 4 does not equal 10. So again, this one was not a solution. That is not a point that worked for both of those equations. That is not the point where they intersect. So that kind of brings us to what we're going to talk about today. Today we're going to be talking about solving systems of two equations. This goes along with page 566 in your textbook. Our objective today is that you're going to be able to solve systems of equations graphically as well as algebraically. So if you have your graphing calculator, this would be a good time to get it out. So what is a system of equations anyways? Well, it's simply two or more equations that are being graphed together. They're on the same plane. And when we look for a solution of the system of equations, it's just any coordinate that is going to be in common to these equations. So it could be a point where they cross. They could be multiple points where they cross. So with a linear set of equations, it's only possible that they would cross one time. When we start looking at different types of equations like quadratics and cubics and trigonometric, they could actually end up intersecting lines in multiple places. So we'll start off with some understandings about linear functions. It is possible that the graphs will never intersect. So in that case, there would be no solution. It could mean that they're parallel. Parallel lines wouldn't have any solutions. And then it could be that they have infinite many solutions. This is when they're lying right on top of each other. So let's move on here. Oh. There are 3 possibilities for the amount of solutions that a system could have. And this would be for a linear system. We talked about that already. Here's what one solution would look like. So you can see that they intersect right here, and that would be the solution point. Parallel lines have no solutions, so this is what they look like. You can see that they have no crossing points. And infinite solutions happen when they have identical lines. So you can see that this blue line back here exists, and then the red line just got graphed right on top of it. So our goal is basically to identify what the exact crossing point is and label it as an ordered pair. So that's a major part of what we're going to do today. And then we're going to extend it to inequalities and hopefully use a little bit of technology to make that kind of come alive for you. So here's our first example. Sorry, today I'm using a different computer than I normally use, so we'll have to see what's going on with the formatting of my lesson. So here we go. We want to solve this system using one of our favorite methods, the substitution method. So what I like about the substitution method is if it's easy to isolate one of your variables, so get one of your variables alone, you can then substitute that equation into the second equation, or third if there happens to be 3. So this is a nice problem for us because both of our equations are actually already solved for y. So we have y alone here and y alone here. That's fantastic news. So since we know that y is really 4x minus 8, we can substitute 4x minus 8 for this y value. That's right over here. So that is what I'm going to do. I'm going to say 4x minus 8, wow, is equal to 2x plus 10. And then this is an awful lot like our warm-up problem at the beginning. All we have to do is get all of our variables onto one side and all of our constants onto the other. So I'm going to actually subtract 2x over to the other side. And then I'm going to add 8 over to that 10. Using the opposite operation will get you right across that equal sign. Okay, so my 8's make 0, 2 x's make 0 over here, and I'm left with 4x minus 2x, which is 2x, and 10 plus 8, which is 18. Good gravy. That equal sign got nuts. All right, so now we just have to solve it for x. Let's see, we're going to divide both sides by 2 to get that x alone. And now we have x is equal to 9. Well, that's fantastic. That means that when we graph this, that it's going to cross, these two lines are going to cross at the x value of 9. But that's not a complete point. We need an x coordinate and a y coordinate. So now let's go ahead and try and find that y coordinate. I can take this x equals 9 value and I can substitute it back into either one of these two equations. It actually doesn't matter. I'm going to eeny, meeny, miny, moe it, so I'll just use this guy. And let's use that to find out what our y value is. We know that y is equal to 2 times x plus 10. All right, well, 2 times 9, which was what our x value was, is 18. And 18 plus 10 is 28. So we just got a y value, or a y coordinate. So let's put it all together. What this tells us is that these two lines are going to intersect at the point 9, 28. So that's our solution. Fantastic. All right, so let's try the next one. This one is a nonlinear system. So like I was telling you before, in a linear system, they're just graphs of straight lines. So the only possibilities is that they're going to intersect either nowhere, like parallel lines, in one place, like our last problem, or they're going to overlap each other because they're actually the same line. So those would have an infinite number of solutions. So this is not a linear system. So we've got a one linear function, and then we have this quadratic function. So our directions do ask us to solve this algebraically. So again, I'm going to use substitution because I already know what x is equal to. They've given us that x is really y plus 3. So I'm going to take this value that x is really y plus 3, and I'm going to use it in my other equation where the x was. So I'm just going to substitute it right on in there. So we know that x, aka y plus 3, is equal to, minus, no, don't do it. I wrote equal, but I meant subtract. Minus the y squared is equal to 3y. Now, normally, I would say probably 95% of the time, I would just solve this for 0, move 3y over to this side. But I'm not going to do that this time because what I'm seeing is that I'm going to have this negative y squared alone here, and it's not going to get anything to add to it to make it positive. So I like to keep my quadratic factors positive if I can. So I'm going to go ahead and get crazy. I'm going to move everything over to the right-hand side. Very unusual, for me at least. It's not that I'm afraid to work with negatives. It's that I just like keeping it positive, you know? So I am using the inverse operation to move everything over to the right. Here, y minus y is 0, 3 minus 3 is 0, negative y squared and positive y squared is 0. You know what we have on the left? 0. That's what we have. Okay. And let's see. I've got a positive y squared. There you are. 3y minus y is a positive 2y. And then negative 3 all alone. Now our result here is a quadratic, and quadratics can be solved a number of ways. We've worked on them already, but this one's pretty easy to factor to solve. So my master product is negative 3, my sum is 2. The two numbers that multiply together to get negative 3 that add up to get 2 are positive 3 and negative 1. So I'm going to just go ahead and factor this. And now we can apply the zero product property. The zero product property says if we have two numbers that are multiplied together and it equals 0, then either the first number we multiplied is equal to 0, so y plus 3 is equal to 0, or the second number we multiplied is equal to 0, so that would be y minus 1 is equal to 0. And if we solve these little equations rather quickly, we're going to get, let's see, y is equal to negative 3, and y is equal to positive 1. But wait, you might be thinking, that's two different solutions. That is absolutely correct. It is possible that we're going to get more than one solution here because these are not a linear system of equations. This guy's quadratic. So we are going to get two different solutions or more possibly. In this case, we are just getting two. It just means that they're going to cross in two places. So let's go ahead and solve that. So here we've got a value of y is equal to negative 3. Well, let's check it out. What if y is equal to negative 3? We can figure out what x would be. So if y is equal to negative 3, then we can use our top equation. And let's go back up there a minute. X is equal to y plus 3. So x is equal to y plus 3. Well, 3 plus negative 3 is 0. I hope you guys were all thinking 0, okay? So one of our solutions is the point. Remember, every point is written in the coordinate x comma y, so that's going to be 0 comma negative 3. So this is just one of our two solutions. Now we got to find the other one. That is the solution where y is equal to 1. Let's move our homework problems over. If you're checking it out in the text, these are the problems, 13 through 18. So now let's test it out if y is equal to positive 1 rather. So we'll use the same equation. X is equal to y plus 3. So in this case, y was 1, so we're adding it with 3. And I get x is equal to 4. So our solution point is going to be the coordinate 4, 1, because when y was 1, x gave us 4. So we have two solutions. They're going to intersect in two places. And so I do just want to show you guys what this looks like graphically. So we can see this actually is flipped because it's not actually the x is squared, it's the y. And we can see right here where our solutions lie. And this is exactly what we just found. So we can imagine that linear function, that x was equal to y plus 3, is this line right here. And that weird quadratic looking one is this guy. And we can see that they intersect at the points 4, 1 and 0, negative 3. All right, let us move on to the next. No, I think we're going to move along here. All right, so this brings us to example number 3. Now, this is one of my favorites. This is solving a system using the elimination method. Now, I love the elimination because we actually get to shrink these equations down. It's one of my favorites. So the whole idea is that you are going to be able to get either your x values to cancel out from both in one step or two, or you're going to get your y values to cancel out in one step. So looking at this, adding these together, I'm not going to get a 0. And that's okay, because we can actually just multiply this whole second equation by 3. You might think, wow, Ryeski, you really lost it today. But no, I promise I have all my marbles. If I multiply every single number in this whole second equation by 3, check out what's going to happen. My top equation, that's not getting changed at all. That's still going to be 3x plus 6y equals negative 6. But my bottom equation, this is going to change. So 3 times negative 5x is negative 15x. 3 times negative 2y is a negative 6y. And 3 times negative 14 is negative 42. Nice. So now you can see that, lo and behold, these y values here, oh, I did not pick a good color to point at that. So here, let's go with red. These 6 y's do make 0 now, because one's positive and one's negative. And so I'm going to, like old school, elementary school, just add up my columns here. So I've got now negative 6 plus negative 42. That is going to give me negative 48. I've got 6y and negative 6y, that's 0, I don't need that. And 3x and negative 15x is going to give me negative 12x. Now we're one step away from finding out what x is equal to, if you can believe that. Since x is getting multiplied by negative 12, we're going to divide both sides by negative 12. And we get that x is equal to 4. So since negative 48 divided by negative 12 is 4. Fantastic. I'm actually going to start my coordinate. So I know my x value is 4. I just need to find out what my y value is now. So it doesn't matter which equation that I substitute in. I could substitute it into this top one, this one before we multiplied through, or even the one after we multiplied it through. It really doesn't matter. So I would just pick one. I'm going to just go with the top equation. Probably I do that most of the time. So we've got 3 times x, but of course x was really 4. Times, so 4 times 3 plus 6y was equal to negative 6. And we're just going to solve it for y. 3 times 4 is 12. And I'm going to move all my constants to one side, so I'm going to subtract 12. And I get 6y is equal to negative 18. One step away from finding out what y is equal to. I'm going to divide both sides by 6. And I've got y is equal to, let's see, negative 18 divided by 6. That's going to give me y is equal to negative 3. So that is our solution point. That's where these two lines are going to intersect. And they're linear equations, so it makes sense that there's just one solution. And that's the elimination method. So in this one, just to reiterate, I had to multiply one equation, the bottom one, by 3 so that I could get my y's to cancel out. But you don't always have to do it only to one equation. You can actually do this to 2 equations. So let's actually go ahead and you could try that one on your own if you like. Wow. So let us try multiplying both equations. Here we go. So I've got 3x plus 5y is equal to 10. And I also have the equation 5x plus 7y is equal to 10. So in this one, there's not a real easy number that I can think of that I would just be able to multiply 3 by to get it to make a 0 with 5. Similarly, there's not a number that I can think of could easily multiply 5 by to turn it into a -7 per se. So in this case, it's just much easier, I think, to try and multiply both the top and the bottom equations by a number that will get things to cancel out. So I'm going to multiply, ooh, I thought I had picked a color. I'm going to multiply this top one by 5. And then I'm going to multiply the bottom equation by -3. The whole thing all the way through. I think that sometimes when I see students mess up on these ones, they mess up because they forget to multiply the solution side. So make sure you're multiplying every single thing by these two values. So here we go, new equation time. 5 times the whole top equation is going to give us 15x plus 25y is equal to 50. And multiplying the bottom equation, the whole entire thing by -3, is going to give me -15x minus 21y is equal to -30. Okay, so I can see it now, can you? Because now we've got the 15x and -15x, which is going to make a 0. That means that x has been eliminated. And we've got 25y minus 21y, which is 4y. Then 50 minus 30 is 20. We are only one step away from finding out what y is equal to. So we're just going to divide both sides by 4. And I get y is equal to 20 divided by 4, aka 5. Sweet. So I've got the y coordinate of my solution. And we can set it up if we want. I always think it's a good idea to set up your solution point in advance, because sometimes people will forget, oh, I'm in the middle of solving a problem, I got a solution, and they just want to move on to the next thing. But remember, it always comes back to, this is where these two lines are going to intersect. So we do need to have an x coordinate as well as a y coordinate. All right, so we got our y coordinate. Now let's pop it back in here to figure out our x. It does not matter which equation that we substitute that y value back into. We got 4 equations up here. You just pick one. I'm going to go with the top one. We don't have to get fancy. So I got 3x plus 5 times y, which was really 5, is equal to 10. 5 times 5 is 25. I'm going to subtract 25 over to the other side. And we get 3x is equal to -15. So our x value has to be -5. Let's pop that bad boy right up in here and finish up our problem. So, oh my goodness, that handwriting looks terrible, Mrs. Rajewski. Alas, I'm just getting used to working on this new tablet. I promise it'll get better. All right, fantastic. So those are basically the two methods I think that are the best for solving a system. Of course, you can always go back to graphing as well. I love to graph, so that would be your third option here. And now we're going to go ahead and move on to solving systems of inequality. So we're going to solve these by graphing as well. All right, so let's go. Now we are going to solve these inequalities by graphing. So this is a system of linear inequalities. I can tell because obviously they are inequalities. They do not have equal signs. And they're linear, don't have any squares, nothing going on crazy around here. So The first thing that I want to do is kind of solve them for y. It's a lot easier to graph them when they're solved for y. And luckily, one of these is already solved for us. So I just have a little bit of work to do on the other one, and then they'll both be solved for y. So I'm going to do this one in blue. So let me highlight my pen. And we will go ahead and solve it. You can hear the kiddos in the background there. So we are going to start by subtracting 2x over to the other side because we're trying to get y alone. Nice little linear function. And now I've got 4y is less than negative 2x and positive 4. Now y is getting multiplied by 4, so I'm going to have to divide by 4 in order to get y alone. But we can't just go around dividing by 4. We have to divide everything by 4. It's a dividing by 4 party. Everybody's invited. So we are dividing by 4. It's going out of style. 4 divided by 4 is 1, so I got 1y is less than, let's see, negative 2x divided by 4 is the same as negative 1/2 x. And then 4 divided by 4 is 1. All right, so I've got y is equal to negative x plus 2, and is less than negative x plus 2, and y is less than 1/2 x, negative 1/2 x plus 1. So let's go ahead and graph these. This first guy, I'm going to go ahead and graph him in red. I like red. So this is a linear inequality. I'm going to start at the beginning. So I'm going to start at 2. And then we are going to use our slope to find the next point. So the slope here is a negative 1, so that's telling me to go down 1 and over 1 from that b value that we previously plotted. And I'm going to just keep using that slope, down 1 over 1, down 1 over 1, to create this line. So then this is an inequality, doesn't have an equal sign, so I'm going to use a dashed line, if you guys remember that from pre-algebra. So let me pull out the good old line of dashedness, and we'll go ahead and, oh, good gravy. We don't want it to be black, we wanted it to be red so that it matches. And here we go, and honestly, so that it really stands out. So here we've got our dashed line, and you would think, okay, we're done. Nope. Because what an inequality does is it splits your plane that you're working on. So it's going to split our coordinate plane into two sides. The side that has solutions and the side that doesn't have solutions. And so this says that y is less than this other stuff. And that tells me that these solutions are all going to be below. So I'm going to use my highlighter. I'm going to make it big. And I'm going to highlight all this area that is below that line that we just drew. This is where all these red solutions are going to be located. Okay, anything underneath the line. Again, I can tell it's going to be underneath the line because this was a less than inequality. Anything that's actually on this line is not a solution because it's not equal to the line, it's below the line. Okay, so those dashed lines are actually pretty darn important. So now let's go ahead and graph this blue line. So here my y-intercept is positive 1. Oh, look at you, little positive 1. And our slope is negative 1/2, so I'm going to go down 1 over 2. Down 1 over 2, and I could keep doing this. And then go ahead and graph a dashed line, because this one also is an inequality, doesn't have an equal sign underneath it. And we will extend it out. Oh, come on, graph. Sometimes it's a little tricky. Okay, so that's pretty good. Now we have to highlight what's underneath the line because this does say that y is less than this inequality. So get out my trusty highlighter again, this time with the blue, And we are going to highlight everything that is underneath this blue line. All right, so check it out. You can see very clearly that there's this like just red area and there's this just blue area, but then we've got this like double overlapping area. This area is where all the solutions are going to live for these inequalities. So you could pick any point that's in here, and I mean it, any point, and we can test it. Now, I will tell you, I have a favorite point. My favorite point is the point 0, 0. Now, when it's in what appears to be the overlapping situation, I like to test it to see that it's true. When it is not in the overlapping situation, I like to test it to show that it is not true. I like using the point 0, 0. In fact, I usually do use the point 0, 0. The only time I don't is when one of these lines is going directly through, you guessed it, the point 0, 0. So the origin's great. It's easy to work with. So let's test the point 0, 0. If x is 0 and y is 0, let's see what happens. Well, if x is 0 and y is 0, for our first inequality, I get 0 is less than 2. That's true. All right, so let's move on over here. How about the point 0, 0? Does it work for this guy? 0 is less than, well, negative 1/2 times 0 is 0. Plus 1 is 1. Is 0 less than 1? It absolutely certainly is. So we have found that the point 0, 0 lives in the section that all the solutions live in. Our job is done here. So our graph picture here is our solution. Fantastic, huh? Now this next one is going to look a little wild, so we are going to utilize our calculators, and I'm really hoping that the emulator I downloaded today is going to work out beautifully for that. So here we go. Let's see. Cross our fingers, people. Otherwise, you can just use Desmos, but here we go. So wowzers. Here we've got a lot of constraints. We want to find a minimum and maximum value of an objective function subject to these constraints. And there's a lot of them. Now, right away, I want to tell you, you should definitely solve each of these for y. So get the y alone first. That's going to be my first goal. So I'm going to go for blue for this first one. So let's see. 5x plus y is greater than or equal to 60. Well, I'm going to subtract 5x right away. So now I've got y is greater than or equal to negative 5x. Remember, I just said I was going to subtract it to the other side, plus 60. Awesome. So let's pop that into our calculator. Calculator. Okay. It would be helpful if we can see all that, but I'll move it out of the way in a second. So in your TI, I believe if you highlight your equal sign and hit enter, you're going to be able to put in an inequality. Oh my emulator is not working out for that too well. So this is a greater than or equal to symbol. So what I want is to have it highlight underneath the line. So I'm going to go move my arrow over until I see this underneath the line indicated. Or actually, this is a greater than symbol, so we're going to want that to be above the line. I don't want it to be dashed. I do want it to be solid because we do have an equal sign here. There it is. Oh, goodness. So I got an above the line and the okay. Now, I do believe on my personal calculator that it will actually have the inequality symbol as well, but emulator, you know, we do what we can, right? So I'm going to go through and hit enter and okay. And now I'm going to go ahead and pop this into my calculator. So that was negative 5x negative 5x plus 60. awesome. Now, go away. Actually, let's go ahead and graph it and see what happens. I'm going to change my window right away because plus 60 is a pretty large number, and my windows usually only go from negative 10 to positive 10. So let's go negative 10 to, let's go crazy. Let's go 100. And we'll do the same thing for y. We'll go all the way to 100 as well. We may need to adjust this, but for right now, let's just see what happens. Woo! All right, so this is showing me a graph of the line negative 5x plus 60. We do have a solid line because there is an equal sign underneath here. And it's highlighted above the graph because this says that y is greater than or equal to. All right, so I'm going to just move that out of the way. All right, next, let's graph this next one and let's make it red. Why not? So here's our line. This is not solved for y yet. Hey, I said let's make it red, for goodness sakes. Red. Ah, I see what happened. I was on the wrong tool. Okay, so with this one, I'm going to subtract x to the other side right away. So I've got 6y is greater than or equal to negative x plus 60. Now you might be trying to remember, what are those rules with inequalities again? It's when you multiply or divide by a negative number that your inequality sign is going to flip. I just subtracted x to the other side. That's not going to flip my inequality. It's only when I multiply or divide by a negative. And here I am going to multiply or divide, but not by a negative. I'm going to just divide by positive 6. So this is not going to affect my inequality symbol at all. So I've got 1y, or just plain old y, is greater than or equal to, it looks like negative 1/6. Plus, well, 60 divided by 6 is 10. So we'll go ahead and graph that now. Ooh, I forgot my x. Okay, so let's get out that calculator. And let me see if I can switch sides. Oh, yes, that's very nice. Okay. Can you guys see that okay? I certainly hope so. It'd be nice if I had some feedback, huh? All right, so here we go. I'm going to go down to this next one, and I'm going to highlight my equal sign and hit enter. And let's see. Come on, enter. All right, yes, it's red. Very good. And let's see, we're going to move this over. Now this does say that y is greater than or equal, so I do want it to highlight above the line. So you see how this like triangle is above like where the line would be. So we're good here. In this menu I could also change which color I wanted. Now if you don't have the color addition, that's not going to be very useful, and I don't even think it will be there. But there we are. And we should type in our inequality now. So it's solve for y. I need negative 1/6 x. So alpha y equals, to make our nice little fraction. And I've got negative 1/6 times x plus 10. Okay, let's graph and check it out. Oh, hello. All right, so you can already see where that overlapping stuff is at. Cool. All right, and now let's see where we're at. Ooh, we've got this next one. So I think on my calculator, it said that black was coming up next. So let's go ahead and use black. So in this one, we've got a lot of things going on. Here we go. So I'm going to subtract 4x to the other side. So I've got 6y is greater than or equal to 4x negative 4x, because we subtracted to get it to the other side, plus 204. What? And you know what I'm going to do? I am going to take this graph out of here because, as you know, we are going to calculate this on our calculator. So now, 6y. 6 is multiplying itself to y, so we are going to have to divide. Let's divide. It's a dividing by 6 party. Everybody's invited. Did you bring a guest? I hope so. Negative 4x divided by 6 is negative 2/3 times x, of course. And we are going to add 204 divided by 6, which is 34. Ooh, alrighty. So let us get that calculator ready to go. I'm going to go back to the y equals graph, run down here to y, the third y equation. We're going to highlight our line and hit enter. And this time we are going to try, let's see, this does say that y is greater than or equal to negative 2/3 x. So again, this is going to be above the line. So here we go. Okay. And now we are ready to enter it in. I need a negative 2/3 x. So alpha y equals, to make our equation, our fraction, I'm going to use negative, not a minus sign, to make negative 2/3. I like to put my x on the outside of the fraction. It does not matter. You can put it in the numerator if you like. Don't put it in the denominator. That'll be a problem. And bada bing, bada boom. Now, you can also see here that there's a couple other inequalities that we can graph. X is greater than or equal to 0. That just means we're going to be above the x-axis. And y is greater than or equal to 0. It means that, x being greater than or equal to 0 means that we're going to be to the right of the y-axis. Y being greater than or equal to 0 means we're going to have all positive y values, so we're going to be above the y-axis. You could graph that if you want. I don't really think it is necessary, as long as we're restricting our viewing just into quadrant 1. Whew, check that out. Okay, so I want to go ahead and take a snapshot of that. Not there. Oh, little picture of Miss Ryeski's email. That's cool. Here we go. All right. Well, now that's lovely. Can you see on this graph the area where we are going to have all of our solutions? I'm going to highlight this in white, I think. It's all of this kind of like purpley area here. And I'll go ahead and tell you that I calculated some of these points that were important. In fact, let us erase this because this has some negative x value. We know that x has to be positive. So let's go up through here. Oh my. All right. So wow, there we are. It's not my most beautiful drawing. Sorry about that. And now let's go ahead and see what are these constraints that they're talking about. So they're taking 7x plus 4y and they're saying we want to know what the minimum and the maximum values of this function are given these constraints. So I'm looking at kind of the points where interesting stuff is happening. So the first point where something interesting is happening is right here, right? So this is the intersection point where x is 0 and y is 60. So let's find out what's happening where x is 0 and y is 60. Another interesting point on this graph is this point right here. So this is the point where x is 6 and y is 30. And you can use the alpha calculate feature, or I'm sorry, your second and then trace feature on your calculator to find the intersection of the points. I don't want to waste a lot of time here going through all that. So that second point here that's pretty interesting is the point 630. And basically just looking at all of these kind of restricted points along the edge here of our graph. This point right here where it hits the x-axis is another interesting point. And we can find that.